Well, thank you everybody for coming, and thank you very much for inviting me. It's a great pleasure. I wish we could do this in person, as we did recently in Poland. I had a wonderful visit. So I'm assuming that many of us here are scientists, but that not many of us are scientists, are neuroscientists, or let alone scientists of consciousness. So I'm going to take this really from the beginning, and try to give you an introduction to this field of research that I'm involved in and that I find truly fascinating. I will take a very materialist scientific stance on consciousness. That's the approach that we take, but that doesn't encroach upon greater phenomenon that are beyond science. So let me put up my first slide. There we go. And can everyone see that okay?
Not yet, I think.
Oh, okay. So let me see what happened. Oh, right. I have to share the screen. Okay. Okay. Now you should see a photo, and then you should see a PowerPoint slide.
Yes.
Great. Okay. Okay. So here we go. So I'd like you first to imagine that I present this simple model to you as a model of you. I say I've studied the human being, and I've come up with this very simple model that, broadly speaking, captures it. So you have sensory input, you have some sort of internal processing, and that processing could be about the sensory input or could be about the processing itself, and then ultimately you have some sort of output that I've labeled behavior. Now, if I were to present that to most people, I think they would say, well, no, that doesn't describe me. There's something missing, right? That could describe my garage door opener, but it certainly doesn't describe me. There's something else. And that something else is that I have this internal subjective experience of the world. I don't just process input, but I actually experience it. It's something personal, it's first person, it's internal, and as far as I can tell, I'm the only one, each of us is the only one who has direct access to our own inner experience, which I'm referring to as this something else. And I talk about it as something else because it's something that's not necessarily implied by the internal goings on in your brain, right? And it's also something else because it seems not to be necessary from a survival point of view. So pain is a very good example. So let's imagine that you touch a painful stimulus with your hand, could be something sharp or hot, and you receive a painful stimulus, which your brain processes. So here are some things that might happen. You're going to withdraw your hand from the painful stimulus. And now if you have an injury, you're going to protect the injury. That also makes good sense from a survival point of view. And very importantly, you're going to learn something, which is don't do that again, right? Because that led to damage. And in the broadest sense, that seems to exhaust the things that are really necessary from a survival point of view. And yet we all know that there's something missing from this simple characterization of this event. And what's missing is that it hurts, right? Again, we have this inner experience of pain, and that for some reason it seems not to be entailed by what's necessary for survival. And what's missing, what we might say, that inner experience is what we call consciousness, what we think of as consciousness. One of the canonical examples that's often used to illustrate what consciousness is and what it's about is the paradoxical phenomenon of blind sight. And now in cases of hemianopia, where someone has had damage to their visual cortex, they may lose vision in part of their visual field. And in the case that I've illustrated here, this patient had damage to his left primary visual cortex, which left him blind on the right side of visual field, with a bit of macular sparing here, which this region around the fovea is often spared. But out in here, there's no vision anymore in that patient. What's unique about blind sight is that you can present stimuli out here in the blind part of the patient's visual field, and the patient will deny seeing anything. And if you ask them to respond to a stimulus that you present there, they just won't respond because there's nothing to respond to. But if you goad them into guessing, if you kind of force them to guess, you say, I know you don't see anything there, but just guess. For example, I'm showing you a rectangle. Can you tell me if it's oriented horizontally or vertically, and just guess? And the surprising thing here is that they guess quite well, over and over and over again, far better than one would expect by chance. So clearly there's visual information that's reaching some parts of their brain, but it's bypassing structures that, for reasons we don't yet understand, give the feeling of seeing. Right? And so by exclusion, you can say blind sight sort of illustrates what consciousness is. That's what's missing in that blind hemifield. The patient can still perform some kinds of what we would consider visual tasks, but doesn't have the conscious feeling of seeing anything. And I'll come back to blind sight again at the end, because it highlights other very important aspects of consciousness. Another good example that gets close to what consciousness is about is somnambulism. So people who are sleepwalkers, they will, during the night, they'll get up and walk around and do relatively complex sorts of actions. They can even sometimes drive a car without crashing, walk around without bumping into things, and even sometimes talk to people. And yet they're, as best we can tell, they're not conscious, right? Everything they're doing is as if they were an automaton. And so, again, this is another example where you can say, well, what's missing here? That this person can do some kinds of relatively sophisticated behaviors, and yet there's nothing. It's like it's all dark inside, right? Consciousness is missing. Another test case for the study of consciousness, and one that's become more prominent in recent years, is in the case of coma and disorders of consciousness, where someone has sustained a brain injury and have lost consciousness or have lost the ability to communicate. They're unresponsive. This is a particularly compelling test case, and the field has developed some techniques for actually using brain activity to infer the presence of consciousness in such patients. The problem here, however, with this particular case is that it's not really selective for consciousness. So when you've had this kind of brain injury, yes, you lose consciousness, but you lose a lot of other things as well. And so you might think of this as really quite more of a blunt instrument in the study of consciousness. This is more like being offline versus being online. Fruit flies, for example, sleep and have sleep-wake cycles, but I'm not sure they're conscious in either of those states, right? So being offline versus online that's a bit more dubious as a test case for consciousness, but I bring it up here because it's one that's been very prominent in the field. And this highlights a subtlety in the use of the word conscious or consciousness. And in fact, we in everyday usage, we use it in two different ways. And so I want to draw your attention to that. One way that we use the word conscious or consciousness is to refer to a state of arousal. So the dog on the left is not conscious, the one on the right is. This is like being offline versus being online. The other way we use the word conscious is in a phrase like conscious of X. So in the lower graphic, in the lower photos there, both of those cats are online. They're both awake and alert. That's not the question. The question is that the cat on the right is conscious of the mouse and the cat on the left is not. And this meaning of the word consciousness is really the important one that we're studying in the field. It's whether or not we're having an inner experience of something, right? And we could say, like in the case of blindsight, whether we're having any inner experience at all. Now, that's something else that I alluded to using this simple model that I started with is extremely difficult to operationalize and isolate for science, because science is by definition an objective mode of inquiry, using third-person measurement, and consciousness is sort of by definition a first-person phenomenon. It doesn't seem to yield to this standard kind of measurement that we do in science. So I can measure neural processing in your brain. I can measure brain activity in various ways. I can measure your behavior in lots of different ways, pressing buttons, and I can measure various physiological responses like your skin conductance and your pupil diameter and your heart rate and breathing and so on. But there's something else that we presume ought to be there, consciousness itself. I don't know how to measure that independent of these other things, right? These physical phenomena that I can measure. So one way to try to get a handle on what we mean by consciousness is to kind of list all the things that we don't mean when we talk about consciousness. So neural information processing, for example. The lowly earthworm performs neural information processing, and I doubt that earthworms are conscious. So that by itself is not sufficient for consciousness, and neither are things like grouping and segregation and vision, or object representation, or even metacognition, the ability to have thoughts, or at least information about your own neural processing, right? None of these in and of themselves is sufficient for consciousness. And by the way, these three at the bottom, neural information processing, grouping and segregation, object representation, collectively, these make up what we call perception. Right? And perception can't be the same thing as consciousness, although it's very, very tightly attached to consciousness. It can't be the same thing. Otherwise, we wouldn't need a science of consciousness. We could just study perception. So if none of these things is sufficient to account for consciousness, to explain it, what is, and I would argue that consciousness is the process by which neural information becomes subjectively experienced. And so the question is to understand how that happens and how that works and why. Now, some have argued that we can access our conscious states directly by introspection. That is arguable, and I do believe that we can access our inner states by introspection. The problem is the moment you record anything about it, or tell anyone about it, or press a button, or do anything like that, it becomes behavior. And furthermore, here, according to the philosopher Thomas Metzinger, introspection is really just another kind of processing. It can access the information content of consciousness, but not consciousness itself, right? So that leaves us, I mean, I've kind of painted this picture of quite a quandary, right? Is there even anything like a consciousness science that's possible, right? And it's for these reasons that consciousness has not always been considered a legitimate object of scientific inquiry. When I was getting my PhD, it was right around the time when it was starting to be a little bit more accepted by the scientific establishment. But as early as 30 years ago, it wasn't. Here's a quote from Stuart Sutherland, famous quote, who says that consciousness is a fascinating but elusive phenomenon. It is impossible to specify what it is, what it does, or why it evolved, and nothing worth reading has been written on it. That rather glum view has largely subsided, and consciousness really has become a legitimate object of scientific inquiry that's now mostly accepted by the scientific establishment. But it's still a problem for science. And the problem posed by consciousness, I think, is very well illustrated by some well-known thought experiments. And I'll just mention these briefly. There are others. These are my three favorites: Leibniz-Mill, the story about Mary, the colorblind neuroscientist, and the idea of a philosophical zombie. Leibniz, in the 18th century, he surmised that if we could enter in to the brain as if it were a mill, then and we could see the parts inside and how it was working, he says we should only find on visiting it pieces which push one against another, but never anything by which to explain a perception. And by a perception, Leibniz, at the time, perception and consciousness were not distinguished as they are today. So he really meant consciousness. Another thought experiment, and some of you who may have heard of these. So Mary, the color neuroscientist, in this thought experiment, so Mary is a neuroscientist who studies color. She studies color vision, but she herself is colorblind. So she doesn't see any color and never has. And yet, as a neuroscientist, we imagine in this thought experiment that she knows everything there is to know about color vision, exactly which neurons are involved in the brain and how information processing proceeds from the retina to decisions about the color of objects, and absolutely everything, right, in this thought experiment. And so the question is, if one day Mary has a treatment that now restores or gives her color vision, and she walks out now into the world and actually sees color, does she learn something new? And obviously, this thought experiment is meant to sort of pump your intuition that, well, wait a minute, we agreed that she knows everything there is to know about color vision, and yet, intuitively, at least, it seems that when we correct her vision, when we give her color vision, and she can see color for the first time, intuitively, it seems like, well, she certainly did learn something new. She learned what it is like to see color. And so, again, highlighting the point that the physical facts about neural processing in the brain don't seem to logically or necessarily entail subjective experience. And the last thought experiment, and these all are really hitting at the same point, is the concept of a philosophical zombie. So a philosophical zombie is not a zombie like in the horror movies, like what I have on the screen. In philosophy of mind, a philosophical zombie is someone who looks and behaves in exactly the ways that you do, spontaneously or in response to stimuli, but for that zombie, for that being, it's all dark inside. there's no consciousness. And just the fact that we can conceive of and entertain the possibility of such a thing, again, suggests that the physical facts about this being and the physical facts about its brain don't necessarily entail this inner subjective experience. So these all, Leibniz Mill, Mary, the colorblind neuroscientist, the philosophical zombie, are all talking about the same thing, which is the age-old mind-body problem, also more recently known as the explanatory gap. You may have heard that term, or the hard problem of consciousness. And throughout history, various solutions have been proposed. One that, at least in scientific circles, is not really taken seriously anymore was Descartes' idea that the soul commanded the brain and received information from the brain via the pineal gland. And he chose the pineal gland presumably because there's only one. It's not bilaterally symmetrical like as in other brain structures where you have two of them. And it's sort of right in the middle. But of course, there are rare cases where people have their pineal gland removed or don't have one and they're still conscious. They have certain deficits. And that, in spite of that being that sort of interactionist dualism being something that, at least in scientific circles, has been rejected, it's been argued that in the field we've gone on with that same kind of, making that same kind of error, but just in a different sort of way, where we go about studying consciousness as if we were looking for a piece of the brain where everything comes together for the benefit of the internal observer, which is caricatured by this cartoon I have here. I'll just mention that, of course, this is the same sort of error. If you find a piece of brain where you think it all comes together and where consciousness happens, then now you've just pushed the problem up the stairs. However, one thing that's important to note is, although this is a caricature and it seems like a silly idea, it certainly feels this way. And the philosopher Dan Dennett has called this the user illusion. We all share that illusion, and the brain seems to go to great lengths to give us the sense that we're in the middle of all this input and at the controls of this output, even though there isn't really any place in the brain where everything comes together. It's just the brain as a whole. This is really illustrated in one way by what's called the binding problem, which has been a very central problem in the study of consciousness. We know that different, this is in the domain of vision, we know that different features of stimuli are processed and represented in different parts of the brain. So here's an object. It's a red ball that's rolling from left to right in front of someone, in front of an observer. And we know that things like the location of the ball, information about its depth and size, its direction of motion, its color, its shape, those different features are all processed in different parts of the brain. And yet when we perceive the object, we perceive all of those different features all bound together and part of a single object. And how that happens in the brain is called the binding problem. And you can see how that's very central in the study of consciousness, because that's the way subjective experience is. We perceive things as objects with all the features bound together. So with all of these difficulties and challenges I've pointed out, a legitimate question is, does science have anything to say about the hard problem of consciousness, problem of how neural processing gives rise to an inner subjective experience? Is it even possible for the scientific method to ever address the hard problem? Some say no. For example, the philosopher David Chalmers. But what if we set aside the hard problem, right? What can science do. And that was famously suggested by Francis Crick and Christof Koch in the 1990s, said, well, let's set aside the hard problem for now. Maybe that's something we need to leave for philosophers to struggle with, but maybe we can look for neural correlates of consciousness in the brain. Without addressing the question of why, we can look at the what and where. Say, well, what are the minimal neuronal mechanisms that are jointly sufficient for any one specific conscious percept? Right. So, in simpler terms, what's happening in the brain that is correlated with consciousness? And that's a meaningful and important question, because not everything that goes on in the brain is present to you in consciousness. So I'll give you a couple of simple examples. One is just signing your name. So when you're asked to sign your name and you perform the act of signing your name, you're conscious of the request, you're conscious of being willing to sign your name and of holding the pen and of signing your name. Right? And maybe of the look of the resulting signature, right, that you're observing. But signing your name involves the coordinated contraction of lots of different little muscles in your hand. Very sophisticated and complex sequence of muscle contractions, and that's governed by your motor cortex in your brain. That's all happening in your brain, but you're not conscious of any of that. Right? That's not part of your consciousness, and yet it's happening in your brain. Another example is face perception. So, perceiving a face is something that we all do readily and automatically. Here you see these stimuli, which are very devoid of detail, and yet we easily recognize them as faces. We know from work in artificial intelligence that recognizing face is quite a complicated feat of information processing, but the early visual areas in your brain are doing this every time you recognize a face. And again, you have you are not conscious of that processing. You're just conscious of the final product. You see a face and you recognize it. You're not conscious of all the processing that went into arriving at that final percept. So we have something like this. This area here in the middle, highlighted in white, this is what we're actually conscious of, but there's a lot going on outside of that that we're not conscious of, and yet it is happening in the brain. So an important part of the search for these neural correlates of consciousness is to recognize what we call the unconscious alternative. That if we're looking for, the neural correlates of consciousness of seeing a face, we want to factor out the correlates of processing that face that aren't necessarily conscious, right? Of processing that face in a way that doesn't reach consciousness. So now we're just looking at the difference, right? Between something that's processed in a non-conscious way versus that same object being processed in a conscious way, right? Otherwise, the science of consciousness would be doing something arguably very boring. For example, you can manipulate consciousness of a visual stimulus just by closing your eyes, but that's not what we're after, right? What we're looking at is how is that stimulus processed differently in the brain when it's conscious compared to when it's processed in the brain, but in a way that's not conscious. So this has been the search for neural correlates of consciousness has really defined the field for the last 30 years, where we're trying to narrow in on what's happening in the brain that's correlated with consciousness, and again, trying to identify these minimal neuronal mechanisms that are jointly sufficient for a given conscious percept. Now, over, say, the last 30 years, lots and lots of neural correlates of consciousness have been identified, far too many to talk about in any level of detail here, but some of them include high frequency oscillations in cortical tissue, long range synchrony, so synchrony between populations of neurons that are far apart in the brain, that aren't right adjacent to each other. Long-range information sharing. So we can use Shannon's information theory to look at mutual information between different parts of the brain. Complexity is one that's been used quite successfully to infer the state of consciousness in brain-injured patients. Recurrent neural interactions have been proposed as a neural correlate of consciousness, and in my own work, I've studied stability of the neural response as a correlate of consciousness. We find that neural patterns of neural activity in cortex are more stable when subject reports being conscious of a stimulus compared to when they don't. So the search for neural correlates of consciousness, among other things, has led to some impressive advances in techniques to help to identify the state of consciousness of a non-communicating patient. So normally in cases of brain injury, the patient may start out in a coma. Coma is a sort of very specific state that usually lasts for 1 to 3 weeks, and then the patient will transition from that coma into some other kind of a state that can either be a persistent vegetative state, a minimally conscious state, or they can start to show signs of recovering consciousness. And we can also compare to just healthy, normally conscious individuals. And we can actually, using techniques that have been developed over the last 20 or 30 years, we can actually decipher, just by looking at the brain activity of the patient, what kind of state they're in and whether or not they're likely to recover consciousness. So in one study involving long-range information sharing as a signature of consciousness, they found quite striking differences. If you look here between, so these sort of connecting arcs represent the strength of long-range information sharing from between different areas of the brain. And you can just see quite clearly visually, if you look at someone in a vegetative state, there's very little long-range information sharing, and somewhat more in a minimally conscious patient, a good deal more in a patient who's recovering consciousness, and considerably more in a normal healthy subject. So it seems that global sharing of information, and I'll get to that in a few minutes when we talk about global workspace theory, is a good signature of consciousness. I mentioned stability of the neural response is also a good signature of consciousness. So here, this measure called angular dispersion measures something like the inverse of stability, so the instability. And so you can see the control subjects here, the healthy control subjects, have a significantly more stable response to an auditory beep that's presented compared to patients in either a vegetative, minimally conscious, or recovering conscious state. Another signature of consciousness is complexity, and that's been measured, that's largely been inspired by a theory called IIT, integrated information theory. And the idea here is that brain activity in response to a stimulus, or in this case, a magnetic pulse, is more complex when one is in a conscious state compared to when one is not in a conscious state. And by the way that they've measured complexity here is by using a data compression algorithm. And the more compressible a pattern of information is, the, let's say, less interesting it is, or the less complex it is. Pattern of activity that has a high level of complexity is very hard to compress. It doesn't compress very well. And so you can actually use compression, data compression, as a measure of the state of consciousness of a patient. And that works exceedingly well. So in some studies, it's worked as well as being 100% correct, right? In discerning the state of consciousness of a patient, and in identifying those rare patients who are unable to communicate and appear to be completely unconscious, but who are in fact locked in. So who are conscious, but utterly unable to communicate. Those are quite detectable using these means. So one caveat, however, that's come up in the study of correlates of consciousness is that when we try to study consciousness, because it's a first-person phenomenon, we have to ask the subject in the experiment to tell us, were you conscious of that stimulus, yes or no? Or perhaps to rate their level of consciousness of the stimulus on a scale, or to give us some indication of their confidence in what they perceived, etc. So you have to the stimuli and your consciousness of those stimuli in those kind of contexts and those kind of experiments become relevant to the task. For example, I may ask you to press a button if you see a face, and press a different button if you don't. So now those sensory perceptual objects are become task relevant in that case. It's long been noted that a certain signal called the P300, or called the P3 for short in EEG data, so this is milliseconds after stimulus onset. Notice that very often in EEG, the positive is down, negative is up. This is called the P300 because it's P for it's positive going electrical potential, and it peaks at around 300 milliseconds after the stimulus onset. And this had long been heralded as an excellent signature of conscious processing. But it turns out that when you do an experiment where the stimuli are not task relevant, means you don't have to press any button or make any response based on the stimuli, but you're still conscious of the stimuli, that P300 completely vanishes. So that's been an important correction in the field, right? What we long thought were correlates of consciousness, some of these turned out to be related to preparing and executing a motor action in response to the stimulus, rather than just simply consciously perceiving the stimulus. And so that's led to a minor revolution in the field, where now we focus on these kinds of no report paradigms, where the subjects, at least during part of the experiment, they don't give any verbal report, right? They tell us later whether they were conscious or not of the stimuli. Some of these correlates, for example, compressibility, complexity, they survive. They survived this challenge, but others, like the P300, it became clear that they were associated with the act of responding rather than having a conscious percept. So in this time, since let's say the late 80s or 90s, a number of theories of consciousness have emerged, most of them in the context of this search for neural correlates of consciousness. We have, of course, dualist theories like Descartes, but we also have global neuronal workspace theory, integrated information theory, higher order thought theory, orchestrated objective reduction, which is a theory that links consciousness to quantum physical interactions, and a more recent theory called attention schema theory. And there's lots and lots of evidence for each of these different theories. It was interesting that during the lockdown, so during the pandemic, a group in Israel did a nice study where they did a meta-analysis of research on consciousness, and really found that there were these different camps, and each camp was sort of situated around one of these theories, and each camp would consistently find evidence for their own theory. And it seemed as if the field had become very siloed in a sense, right? everybody was trying to find evidence that their own theory was correct, and they were succeeding in doing it. And so we have these are just some of the theories here that I've listed on the screen. This is not an exhaustive list. So this is a field really that has, you might say, a glut of theories, and we haven't been doing a great job of driving a wedge between them, which is something that we've been trying to do more recently. In fact, there was recently a what's called an adversarial collaboration sponsored by the Templeton Foundation, pitting global workspace theory against integrated information theory. That's been actually in the news lately. So I'll see. I'll describe just a few of the more prominent theories. So global neuronal workspace theory, which has really been championed by Stanislas Dehaene, who I worked with in Paris as a postdoc. So this theory goes back to a psychologist named Bernard Bars, who first proposed global workspace theory, and then Stanislas Dehaene kind of took that theory and applied it in a neuronal, gave it a neuronal framework, and actually implemented it in a computational model. And the idea is that neural information becomes conscious when it gains access to a quote unquote global workspace in the brain. And this global workspace is a network of neurons which are amodal, meaning they're not attached to any particular sensory modality, and that have very long axons, and so can communicate information widely throughout the brain. So consciousness happens when consciousness of a certain piece of sensory information happens when that information gains access to this global workspace, so that the information can then be broadcast widely throughout the brain. Another prominent theory, integrated information theory, which has been championed by Giulio Tononi, arguably the most well-known theory of consciousness. This says that consciousness in any sort of information processing system is a function of the degree to which that information is integrated and differentiated. So Tononi uses very often the example of the pixel array on your digital camera, on your smartphone. So there's a large array of pixels, but they're not at all integrated. Each one is separate, right? Whereas the way things work in the brain, when you have a visual stimulus, that information is integrated in a special way, and at the same time differentiated, which means that any given subjective experience that you have, right, can be differentiated from a very, very large number of other possible states. So having a specific conscious percept is highly informative, because it picks out one of a very, very large number of possible states. And this level of integration and differentiation can be measured actually in a system mathematically, giving you a value called phi. And the higher phi is, the more conscious that system is. And this is thought to apply to systems more broadly. One of the problems with integrated information theory is that it tends to lead you down this road to panpsychism. So saying that basically everything is conscious, it's just a matter of degree, and humans are highly conscious, but an earthworm also has a little bit of consciousness, and not everyone subscribes to that idea. One last theory I'll mention, so this is also quite a prominent theory, is higher order thought theory, originally proposed by the philosopher David Rosenthal, and that's now been given sort of a new sheen by looking at higher order neuronal representations as a substrate for it. The idea here, you have a brain representing or encoding a visual object, a peach. And according to higher order thought theory, that percept becomes conscious when the brain entertains another representation, which is a representation of the brain representing the peach. So that's a higher order representation or a second order representation. And having a representation of the brain representing the peach or representing a certain stimulus is considered to be necessary and sufficient for that state to be conscious. So these are just three of the more prominent theories. There are many others. One of the main problems with these theories is that none of them addresses the hard problem. So they're descriptive, they're not explanatory. And they were never intended to be because they were couched in the and built up in the language of neural correlates of consciousness. So when you get, for example, to the point of there's a higher order thought, well, what gets you from there to there's a subjective experience? It seems as if magic is required, and these all push you towards either dualism or panpsychism, which aren't a great starting point for getting anywhere with science. So that's really the upshot of why consciousness is a problem for science. Once again, looking back at those thought experiments, it's a problem that consciousness is by definition first person, and science is by definition a third person enterprise, right? And so we have a sense that there's something else that is part of who we are, other than just input, processing, and output. And yet when we look inside the brain, right, at least physically looking at what we can measure, there is nothing else, right? And all of these great thinkers throughout history have said as much. So one type of theory that's tried to get around this problem is called illusionism. Illusionism is not itself a theory, but it's a kind of theory. The most prominent illusionist theory at present is called attention schema theory. It is developed by Michael Graziano at Princeton. And it tries to address the hard problem. And it does so in a way that at least is valid scientifically, even if not entirely satisfying. So many people aren't satisfied by this theory, even though they, I guess, have to admit that it, in a limited way, is valid. So I'm going to tell a little story that sort of illustrates what illusionism is about. The idea, the gist of illusionism is that consciousness is itself a perceptual attribution. And so as the story goes, and this was recounted by Michael Graziano in his book, there was, and this apparently is a true story. So there was a neurological patient who had sustained a brain damage. I believe it was through a stroke, and he was being seen by his neurologist, and he said to the neurologist, "Well, I have a squirrel in my head." And the neurologist said, "Okay, well, I mean, I assume you mean that you have the thought of a squirrel, right? And you just can't get that thought out of your head, just like sometimes you have a melody in your head that you just can't get out of your head." The patient replied, "No, absolutely not. It's not the thought of a squirrel. It's I actually have a squirrel. I actually have a furry animal living inside my cranium." And of course, when told that a cranial rodent was illogical and incompatible with physics, the patient agreed. He said, "Look, here's your brain scan. There's no squirrel in there." But then the patient went on to note that logic and physics cannot account for everything in the universe, and he remained convinced that there was a furry animal living in his cranium, even though he at the same time understood that that was illogical and not possible and not at all consistent with any of the evidence, like his brain scan. So the question that is relevant here and that illusionism poses is that if you were a scientist working with this patient, what would you seek to understand in this case? Would you start searching for the squirrel, or would you try to figure out why this person believes he has a squirrel in his head? Clearly, in that case, I think most scientists would opt for the latter. And illusionism says we should really do the same thing when it comes to consciousness. So I'll try to describe the essence of the idea using an example showing how consciousness is at least a perceptual attribution. Right? So you imagine that one day someone comes and knocks at your door, you answer the door, and it's a long lost friend who you haven't seen for many years. And you start to have some conversation. How have you been? You recount what's happened over the past, X number of years, and they do likewise. And after a few minutes of conversing with this friend, who obviously you perceive to be as conscious as you are, you realize that something's not quite right. And eventually it becomes clear to you on closer inspection that this isn't your friend at all, that this is just an android. This is an imposter android who looks like your friend and who was designed to fool you, at least for a short bit of time, into thinking it was really your friend. So it's just an android and not clearly, or let's say for the sake of the thought experiment, not conscious, right? The moment you realize that this isn't your friend and that it's just an android, your perception of that thing in front of you changes dramatically. Whereas at one point you attributed consciousness to it, now you don't, right? So this thought experiment helps you to sort of see that consciousness is, again, at least a perceptual attribution. We attribute consciousness to others and also attribute it to ourselves. But it easily vanishes, right? When we conceive of something as being incompatible with what we think consciousness is, like being an android. So this is sort of the essence of what the angle that illusionism takes. Some people have argued, well, what about phenomenology? Illusionism deals nicely with the meta problem of consciousness, which is how we attribute conscious states to others and ourselves, but it doesn't explain subjective experience per se in the immediate sense. Now, you might argue, well, that's just like saying, oh, well, you haven't explained the squirrel, right? Kind of, but not quite, right? I would say that phenomenology is de facto a conclusion that we arrive at. So this sensory perceptual information right here, right now that I'm experiencing is somehow special, or that I'm processing. Something about this sensory perceptual information right here, right now defies explanation. I'm not just processing sensory perceptual information right here, right now, there's something else. So these are all conclusions that we arrive at, right? These are perceptual attributions. So according to illusionism, is consciousness just a shared delusion? You'll find that to be preposterous. Well, not quite. For starters, not everyone shares it. And also, it's not like the case of the squirrel, right? The squirrel example falls short in one way, which is that what the person is perceiving, the squirrel that's inside his cranium, is there's nothing real that corresponds to, right? Whereas in the case of illusionism, at least according to attention schema theory, that inference, the perceptual inference, is about something real and it has a function. In the case of attention schema theory, it's about selective attention, which is a real thing, and a third-person measurable neural phenomenon. So if we take this tack, the illusionist tack, well, then is there anything meaningful left to study? And if so, how should we define consciousness? Well, I'd argue that among other things, consciousness is characterized by a neural behavioral dissociation. There are certain behaviors that we can accomplish without consciousness, and certain other behaviors that necessarily imply or always co-occur with consciousness. And I think this is one of the important fronts in research on consciousness today. It's something that was a big topic back in the 80s and then has been sort of sidelined for many years. And I think this is really the important front, characterizing, trying to understand better what consciousness is, and under what circumstances it necessarily accompanies certain behaviors and not others. One of these, I'll just, for the sake of time, I'll mention one, which is my favorite. Going back to the context of blind sight. So here's again the view from the point of view of this blind sight patient. So wherever he looks, everything off to the right, there's no visual information there. Interestingly, in blind sight, like I said, you can present stimuli and the patient can guess quite well about those stimuli. For example, the orientation of a bar or the direction of motion of a dot, even the emotional expression on faces. You have to tell the patient when to guess. So if you ask the patient, all right, press a button when, right, you see the bar and tell me its orientation, the patient will just sit there and wait indefinitely, even when the stimulus appears, right? So the patient doesn't know when things happen there, even though if you tell them when, usually by playing a little auditory beep or an auditory cue that says, okay, guess now, right? Then they can guess because there's a conscious prompt, something that they do perceive consciously that tells them now's the moment when you should deliver your guess. So in some sense, consciousness seems to know when things happen. It seems to be intimately tied with detection, among other things. There's just one example. So I think in the interest of time, I'll conclude there, but I have a brief postscript, which is about the relationship between consciousness and the soul. Now, I'm not a theologian, so I can't claim to have the relevant expertise here, but I think there certainly are some theologians among us who can help in the discussion to address this question. I know that in common sort of everyday language, consciousness and the soul are considered the same thing. For example, in French, the word esprit means both mind and soul, sort of interchangeably. But based on my understanding of consciousness and the many years that I've researched it, I am doubting that consciousness and the soul can really be the same thing. Consciousness, to me, seems to be too fragile. You can damage your consciousness can be damaged or even taken away by damaging your brain, but that shouldn't, right, damage or take away your soul. Not just damaged, but also altered. But I welcome a discussion on that, since again I'm not a theologian and I lack the relevant expertise. But with that, I think I'll conclude and open the floor for questions. Thank you.